Hello everyone and welcome to our third Tech Talk, where we take a closer look at the technology of our HF high-power transmitter. With me once again is Mr. Träger, who is a senior system architect and designed our HF high-power transmitter. He is the expert when it comes to HF communications. Today, we want to take a closer look at the topic IP over HF. Robert, when you say IP over HF, what do you mean exactly?
HF radios are highly important for secure communications, as used by the armed forces. Internet protocol is the basis of the Internet and the most widely used protocol. It can be operated over HF radios. Doing so is very useful, particularly to enable application support that is only available to run over IP. IPOA stands for IP over air. This is a Rohde and Schwarz proprietary embedded operation mode used to set up communication networks over a HF radio link, providing transparent IP functionality over the air. This means that a radio that is equipped with IPOA includes standard static IP router functionality and can be configured very easily by entering IP subnets to be routed to different destinations over the air interface. The physical Ethernet interface of the radio has a standard IP address used, for example, for remote control. Additionally, a second IP address represents the air interface of the radio, so the antenna connector. An internal address mapping function ensures that data is delivered to the correct recipient. In other words, from an IP layer point of view, the radios act as routers between the wired network and the air network. The IP packets, which may contain digital voice or data information, are transmitted transparently over the radio channel.
Okay, thank you for this definition. In our last Tech Talk, we already mentioned two ways for connecting IP-based applications to HF radios: Stanag 5066 and Stanag 4538. Today, we want to focus on Stanag 4538. Robert, could you briefly summarize this standardization agreement?
Yes, of course. Let us talk about the mechanism for IPOA, IP over air, communication adopted in our HF products at Rohde and Schwarz. This provides a very easy and slim architecture, basically an already very well-proven proprietary solution in use especially in non-NATO countries based on Stanag 4538. The main functionalities of Stanag 4538 describes link setup, the link maintenance, and the data link protocol named XDL. XDL uses a set of 4 defined burst waveforms for packet data traffic. The standard supports analog and digital voice, in addition to circuit and packet switch data. XDL is defined for a point-to-point link and can further be divided in 2 classes of protocols called HDL, that's the high throughput data link, and LDL, the low latency data link. HDL is optimized for delivering large datagrams in good channel conditions. LDL is optimized for delivering small datagrams in all channel conditions and also longer datagrams in poor channel conditions. The different performance of both under various channel conditions is caused by the characteristic of different burst waveforms used. Both protocols employ ARQ, that stands for Automatic Repeat Request, and code combining for adaptation of data rate to channel conditions. HDL and LDL exist in different variants.
Understood. Stanag 4538 also offers a variety of waveforms optimized for data transmission in the HF channels for a variety of channel conditions. However, Stanag 4538 was not designed for HF wideband. Robert, how do we deal with that at Rohde and Schwarz?
Well, due to the inconsistency of the standardization of Stanag 4538, all previously available solutions for narrowband are also proprietary solutions. It is therefore only logical to further develop the extension to HF wideband as a proprietary solution either. This, of course, is based on the proven Stanag 4538 approach. Our Wideband HDL waveform includes both data link protocols, which have been expanded to the higher bandwidth up to 48 kHz. All of them provide complete IP transparency. So, to summarize, the radio channel will always provide lower data rates, will have a higher delay or higher delay variations, and will be more erroneous compared to a wired network. Therefore, it is recommended to use UDP, the User Datagram Protocol, as transport protocol. The IPOA protocol provides radio-embedded Internet protocol functionality that is Open System Interconnection Layer 3. This enables IP communication over air, IPOA, for a customer system by integrating radios into the network infrastructure. The IPOA protocol provides support for several predefined IP services running on the radio, such as text messages, alarm services, GPS services, and GPS immediate services.
Okay, thank you for your explanations. With Wideband HDL, we at Rohde and Schwarz offer a proprietary solution. With this solution, our customers can use the high-performance HF wideband technology for their IP-based applications. Since our Series 4100 radio also acts as a router, this is possible with a significantly simplified system architecture of the integrated communication system. Thank you once again for your time and your expertise, Robert.
Welcome, Sophia.
I'm looking forward to see you for our next Tech Talk. Thank you for watching and stay tuned.